Hello friends. This video will be dedicated not so much to a smart home as to a safe home. We will get acquainted with two voltage relays from the TOMZN brand at once. The first option is the compact TOSVA-16 socket relay, which is simply plugged into a regular wall socket. The second is the TOSVA-16LM, already in the form of an extension cord with several sockets and the same set of protections. Functionally, both devices are identical. They can disconnect the load at overvoltage and undervoltage, protect against overcurrent, display network parameters on the screen, and allow you to set the power on delay. They differ in form factor and the number of digital displays. More details next, but before we start, as usual, I ask you to like this video so that more people interested in the smart home topic can find it, and also subscribe to my channel if you have not done so before. Both models are voltage relays with protection against overvoltage and undervoltage, as well as overcurrent. They automatically disconnect the load in case of an and turn back on themselves after normal parameters are restored. The display shows the current voltage and current, and there is the possibility of calibrating the readings. Both devices are rated for currents up to 16 amperes, with the ability to manually adjust the shutdown threshold. The protection response time, the delay of repeated switching on, and the delay when power is applied. All of this can be configured over a wide range for specific network conditions. In fact, these relays can also work as turn-on delay relays, which makes it possible to separate and time the startup of powerful consumers and reduce the load on the network during simultaneous switching on. The power consumption of the relay itself is minimal, less than 2 watts, and the switching life is stated to be around 100,000 cycles. Now to the differences. TOSVA-16 is a relay in a socket format, suitable for point protection of a single device. TOSVA-16LM is an extension cord with several sockets and a cable about 1.5 meters long, designed to protect a group of devices at once. Both devices arrived in branded boxes from the manufacturer. I ordered them in one order, as I wanted to look at both options. The packaging is somewhat crushed, but the main thing is that the contents were not damaged. This is the box of the socket. What is interesting is that on one side, which was visible on the previous slide, a version with one digital screen is shown, and on the other side, with two. And this is the extension cord. What distinguishes it from ordinary ones is the presence of a digital display and setup buttons. By the way, the manufacturer also has a version with USB ports. The TOSVA-16 socket relay package includes the device itself and a paper instruction manual. There are no additional cables or accessories here. The logic is simple. Plug the relay into the socket, connect the load through it, and you can work. With the extension cord, the same thing, except that only the instruction manual is included. Everything is ready to work right out of the box. The instructions for both devices are quite detailed and describe the operating principle of the relay. They outline the main protection functions, overvoltage and undervoltage, overcurrent, as well as automatic power restoration. It is separately shown which LEDs light up when a particular protection is triggered. The instructions also describe the settings menu in detail. Here you can set the voltage and current trip thresholds, the delay time for switching on and restoration, and also perform calibration of the readings. All parameters are grouped into items. Navigation is carried out using the buttons on the case. So even without experience with similar relays, you can figure it out quite quickly. Let's take a look at the appearance. In terms of form factor, this is a socket adapter with the control unit raised upward. The housing is plastic, without sharp corners, looks neat, and does not block neighboring sockets. The plug and socket are of the standard European type with grounding. On the front panel there is a 2-line digital display. The voltage is shown on the top, and the load current on the bottom. On the right are the control buttons, power, menu entry, and parameter adjustment buttons. Next to the display there is LED indication showing the protection status and device operation. All elements are labeled, the logic is clear, and it is easy to understand. The extension cord has the most standard design, with 4 grounded sockets. All of them are recessed into the housing and spaced far enough apart so that large plugs do not interfere with neighboring ones. The control unit with the display is located on the right side. On the back, the housing is closed with a solid cover, fastened with screws. There are special slots for wall mounting, both in vertical and horizontal positions. The control unit of the TOSVA-16LM is very similar to the socket relay. There is only one digital display here, and it alternately shows the network parameters, voltage, and current. Below it are LED indicators of operating modes and protection. The control buttons are located at the bottom: power, menu entry, and value adjustment. The housing of the socket relay consists of two halves and is tightened with screws. After unscrewing them, the halves separate without effort. There are no latches or hidden fasteners. Inside, everything is laid out quite neatly. The control board and the power section are separated. In the upper part, there is a power board with a relay, power supply elements, and filtering. Separately, in the second half of the housing, there is the indication and control board connected by a ribbon cable. Such separation is logical. The display and buttons are not loaded by power circuits. An electromechanical relay rated at 16 amperes is used as the power element. The connection is made with thick wires. The soldering is neat, without excess solder. A varistor and interference suppression elements are visible, a necessary set for protection against voltage surges. The power input and output are routed through separate contact pads marked line in/line out. The connection is made directly by soldering, without connectors. A microcontroller is installed on the control board, responsible for measurements, triggering logic, and menu operation. The board is secured with screws, and the ribbon cable is laid without tension. Overall, the assembly looks simple but neat, without obvious cost cutting on critical components. The extension cord is disassembled in a similar way. The bottom cover is held on screws. After removing the cover, the entire internal layout is immediately visible. The sockets are connected by brass bus bars. The contacts are solid, without thin jumpers, which is important for operation with loads up to 16 amperes. The socket modules themselves are rigidly fixed in the housing and do not wobble. The control board is located on the side, separately from the socket block. The same approach is used here as in the socket, relay, filtering elements, controller. The power cable enters through proper strain relief, and the wires are routed neatly, with color coding. When power is applied, a timer is activated, which can be set in the range from 1 to 500 seconds, with the default being 10. This makes it possible to separate and time the switching on of high-power loads so that there is no simultaneous surge. In standard operating mode, the upper digital display shows the current voltage, and the lower one shows the current. To enter the settings menu, you need to press and hold the set button. Then, using it, scroll through the menu items. There are 15 of them in total. It starts with setting the delay time after voltage is applied to the relay before it turns on. Next, the threshold voltage values are set. Separately for excessively high voltage and low voltage, 2 values for each, at which the relay should turn off and, conversely, turn on. Separately, the shutdown time when the threshold is exceeded and the delay time when the voltage normalizes are configured. There is also a setting for current limit, the delay time before rechecking the load, and the number of test cycles. There is calibration of current and voltage values. If it is necessary to change a value, use the arrow buttons. For a quick exit from the menu without scrolling to the end, hold the set button. The order of the items and their purpose are described in the instructions. Let's set the value for the lower limit. Item A6 is the shutdown threshold, 170 volts. I set 160. Item A7 is the turn-on threshold, 175 volts. I set 180. A8 is the delay before turning on, 30 seconds. I set 5. The arrow button can be held for fast value changes. A 9 is the delay before turning off, 1 second. I set 0.1. By holding the set button, I exit the menu. For the test, I connected the relay through a dimmer. We lower the voltage. Until the set threshold of 160 volts is reached, it will remain on. When it is reached, it will turn off almost instantly, with a delay of 0.1 seconds. The corresponding LED lights up on the panel, and it will remain off until the voltage reaches the turn-on threshold of 180 volts. After that, a 5-second delay starts and the relay turns on. It is difficult for me to reproduce an increase in voltage, so we will test overcurrent protection. We need item A10. By default, it is set to 16 amps. I remind you that for fast and smooth value changes, you can simply hold the arrow button. In this case, it is just not very convenient for me to do so. I set the value to 4 amps. Item A11 is the delay before rechecking. I set 10 seconds. Item A12 is the delay before shutdown. I set 0.1 seconds. At the moment, the load is not connected. The relay is operating. As soon as I turn on a load whose current is higher than the set value, the relay turns off after 0.1 seconds. Now another LED lights up for overcurrent. Since current cannot be measured without a load, the relay will turn on every 10 seconds. Since the current is still above the threshold, it will immediately turn off. By default, it will do this continuously, so you can set the number of attempts. And if the excess load is removed, the relay will restore its operation. The extension cord works according to a similar scheme. Before turning on, there is an adjustable delay, which will allow you to turn on household appliances not all at once after power is restored. There is only one screen here, so the current and voltage values alternate. Control, value setting, and even the order and purpose of the menu items are completely identical to the socket. The only difference is that both the item number and the value set in it are displayed alternately on one screen, rather than simultaneously on two. Let's carry out similar tests, and before that we will set the shutdown threshold, A6, to 160 volts. Turn on A7 to 180 volts. Delay before turning on to 5 seconds. Before shutdown to 0.1 seconds. Exit by holding the set button. For the test, I use the same dimmer. With its help, I lower the voltage until I reach the shutdown threshold. Then I increase it, and after reaching the turn-on threshold, the relay turns on the sockets of the extension cord. For the sake of experiment purity, we will also conduct a test for exceeding the current threshold. As I said, all menu items here are identical to the previous model. Instead of 16, I set it to 4.5 amps so that it reacts to turning on the test load. The turn-on time, or rather the recheck time, is 5 seconds. Shutdown is 0.1 seconds. The operating principle is the same. Overcurrent turns off the relay, then after a specified interval a check is performed. If the load is still higher, it turns off. If not, it turns on. The number of checks can be configured. For an extension cord that has not one but 4 sockets, such protection is more relevant. From the information obtained as a result of testing, it can be concluded that in addition to the directly stated function of protection against voltage surges, the device can also be used as a delay relay, allowing the switching on of powerful loads to be spread out in time in order to avoid power overload. In addition, a useful option is shutdown when the set current threshold is exceeded, which is especially relevant for extension cords, into the sockets of which several powerful devices can be connected simultaneously, while the load on household sockets should not exceed 16 amps. That's all. I hope this video was interesting and useful for you. I would appreciate your likes. They help promote the video on YouTube. If you are not yet subscribed to my channel, now is the time to do it right now. In the description under the video, you will find all the necessary links to stores where you can purchase these relays, as well as to my social networks, Telegram channels, and a group for discussing smart home topics. Join in, it will be interesting. Thank you for your attention. See you next time, and peace to everyone.